Hi everyone, my name is Mel and I work on the Atlassian Server Ecosystem Engineering team in Sydney. Today, in this 20-minute talk, I'm hoping to give you some insight into what AMPS is and how it works. If you've ever extended an Atlassian server product with an app, you're probably already familiar with the Atlassian Plugin SDK. It's a set of tools and scripts that can be used to build P2 apps for products like Jira and Confluence Server. The SDK is made up of AMPS, Maven, and a collection of shortcut commands that provide the Atlas commands. Today, my talk will focus on AMPS, which is where most of the magic happens. The Atlassian Maven plugin suite, or AMPS for short, is a group of plugins that are used to generate, build, and test add-ons for Atlassian server products. AMPS allows you to quickly start an instance of an Atlassian server application with your app already installed and a temporary license entered. Now, I want to take a moment to clarify the language I'm using in my talk today. When I use the word plugin, I'm talking about a Maven plugin, for example, one of the plugins that makes up AMPS. When I say app, I'm talking about the kind of app that you're building with AMPS in the SDK to extend the functionality of Atlassian products. I hope it clears it up. So earlier I mentioned that the Atlassian Plugin SDK includes a set of shortcut commands. Those commands are actually calling Maven instructions that invoke different plugins within AMPS. AMPS is a collection of plugins which can be divided into four main groups. The Maven AMPS plugin is a collection of classes which perform many of the product non-specific functions of AMPS, such as creating or running an app. The AMPS dispatcher plugin is responsible for dispatching control of the appropriate product specific plugin when a non-specific command like run is used. The product plugins are a hierarchy of plugins for each server application. These plugins extend the components of the Maven AMPS plugin to ensure it works correctly for each product. And finally, the archetype plugins are a set of plugins which define templates to create apps for each product. Don't worry if that all seems a little overwhelming. It took me a while to get my head around it too. So later I'm going to walk through what happens when you call Atlas run, which will help to clarify things. Also, if you're interested in taking a closer look, AMPS is open source and you can download the source at bitbucket.org/Atlassian/AMPS. So now I've given you a brief overview of AMPS, I'd like to introduce some of the technologies that AMPS uses. Understanding the technologies that make up AMPS will help you get the most from it. Then I'm going to walk through what happens when you run an Atlas run command. And then finally, I'll share some tips for using AMPS, and at the end, there'll be some time for Q&A. So please save any questions until then. The three major technologies used in AMPS I'll talk about today are Apache Maven, Codehouse Cargo, and Apache Tomcat. But I should note here that not all server products use all of these technologies. Fisheye Crucible, for example, is a little bit different to the other Atlassian server products. It doesn't actually use Cargo or Tomcat to start, but one of the brilliant things about AMPS is you don't need to know which products do and don't use Cargo. Okay, so let's start with Maven. Maven is a lot of things, which means it's difficult to sum up in a simple way. If you haven't really had much experience with it yet, try thinking of it as a tool to simplify your life. For a long time, all I really knew was that Maven was Maven package, which I guess speaks for how well it can work when configured correctly. Anyway, Maven, with the help of AMPS, knows how to build your plugin and what is needed to build it and start an Atlassian environment with your plugin running. So, is Maven a build tool? Calling Maven a build tool is probably a bit of an understatement. Maven does help you manage your project builds, reporting, and documentation using a project object model, but it does more than just that. Maven is based around the concept of a build lifecycle. The process for building and distributing a particular project is clearly defined. Each build lifecycle is made up of stages known as build phases, which are executed sequentially. If you wish to perform a Maven package, for example, it will go through the stages validate, compile, test, and finally package. Maven is also a dependency manager. It's particularly useful because it can automatically manage massive dependency trees, especially transitive dependencies, For example, where plugin X depends on application Y, which depends on shared library Z. This is pretty common in the Atlassian ecosystem. Using Maven, you can quickly and easily retrieve all dependencies for that your plugin will need and create a working development environment in just a few steps. Finally, you can use Maven as a project template tool. Maven Archetypes are used to get users up and running as quickly as possible by providing project templates. In AMPS, the archetypes can be used by developers to quickly and easily create app skeletons for Atlassian server products like Jira and Confluence. So, now you know some basics about Maven. I could easily spend 20 minutes on Maven or more, but I'm going to leave it there and move on to Cargo. Cargo is a wrapper that allows you to manipulate various different application containers like Tomcat, Jetty, or WebLogic in a standardized way. Cargo is a third-party tool rather than an Atlassian tool. It's available under the Apache software license, and in AMPS, we use Cargo to deploy applications to containers from our Maven builds. Cargo manages the creation of the container, as well as the installation of the application and its dependencies. So, in AMPS these days, the containers Cargo manages are Apache Tomcat containers. A Tomcat container is an open source Java servlet container which provides a Java web server environment for the application code, like Jira and its apps, to run in. Atlassian server products like Confluence and Jira are bundled with Apache Tomcat. It's the recommended application platform for those products. In AMPS, we use Tomcat to replicate that. When you're building an app, AMPS and Cargo take care of managing which version of Tomcat is used, as well as creating and managing the container. I'm not going to go into a lot of depth about how it works, as I think most people who are familiar with Atlassian products will already be familiar with Tomcat, and there are plenty of resources available online if you'd like to learn more about it. Great, so now you're familiar with some of the main technologies that are used to make up AMPS. Let's talk about how they work together. Have you ever wondered what happens behind the scenes when you enter Atlas Run into your terminal? The first time I used Atlas Run, I wasn't really sure what was going on. A lot of stuff appeared in my terminal window, and then a new Jira instance was up and running like magic. Some of these things seem familiar, like the normal startup messages I'd seen when starting Jira and Confluence in the past. But other things were quite different. I'm going to go through what's actually happening when you enter the Atlas Run command in the hope that you'll better understand how AMPS starts Jira. So when you enter the Atlas Run command into your terminal to run your plugin, the Plugin SDK calls the dispatcher, that's one of the plugins in AMPS, to build your plugin and start Jira. Let's walk through what happens. First, the Maven dispatcher forks a separate thread which runs through all the Maven lifecycle stages up to the package stage, resulting in a plugin jar being created, which will be very useful later. Then, it detects which product your app is for, detects the Maven goal, and uses the Mojo executor to run the correct Mojo based on the product goal. In this example, we'll say we're building an app for Jira, so next it will invoke the Maven Jira product plugin. I just mentioned Mojo a few times there. I'm betting some of you are wondering what a Mojo is. A Mojo is simply a Maven goal. A plugin can consist of any number of these goals. A Mojo can also specify metadata about a goal, such as the name, phase of the lifecycle, and parameters it's expecting. At its simplest, it could just be a single class representing one plugin's goal. AMPS is, as you can imagine, much more complex and has Mojos corresponding to many of the Atlas commands, as well as Mojos for behind-the-scenes tasks specific to each different Atlassian server product which AMPS has used. The Maven Jira plugin is part of the AMPS product plugins. So this is how the Atlassian Maven plugin suite manages to allow you to work with different Atlassian server products, all from within a single framework. Usually only one product will need to be executed by default, though this can be modified. However, due to the limitations of Cargo and the way AMPS works, you won't always have success. So the Jira product plugin, so the dispatcher started a process to create a jar from the Jira app and then invoke the Maven Jira plugin. It checks for AMPS and SDK updates, sends off analytics tracking information, determines which Atlassian products need to be executed based on the apps in the pom.xml, and then passes control to the product handler. The product handler is part of the Maven AMPS plugin. It's used to start the product. It extracts the home directory into the target directory within the app working directory. The home directory artifact is specified by the product handler. For example, the Jira product handler specifies the Jira plugin test resources artifact in Atlassian's public Maven repository. Similarly, it extracts the application files for Jira in the target/Jira directory. Finally, it adds artifacts and overrides and merges the system properties defined within AMPS with the ones supplied at the command line, if there were any at the time. Finally, AMPS starts Jira in a container using the settings and overrides and files from earlier. It checks for an existing cargo container in the target directory that can be used and creates one if needed. It uses the settings and overrides to define the container's configuration, deploys the specified deployables to the container automatically, and starts the container. Once the container is running, it will then wait for Maven to receive a signal to shut down, which will also shut down the container. So now you understand what's going on behind the scenes. The messages appearing in your terminal after you type Atlas run will make much more sense. Which brings me to some useful tips for getting the best out of AMPS. The first thing I would like to recommend is using the Atlassian Plugin SDK. I'd strongly recommend installing the Plugin SDK, whether you plan to use the shortcut commands or not. Installing the SDK will ensure you have the correct version of Maven and that your Atlassian Maven repository settings are configured correctly. If you don't want to run Maven commands directly, you can use Atlas Maven rather than Maven. For example, Atlas Maven clean will run a Maven clean operation using the Atlassian version of Maven installed. The second tip I have would be to make the most of Quick Reload. Quick Reload is an Atlassian plugin that significantly reduces plugin development iteration time. It works by watching output directories for jar files to be created and then automatically uploads them into your running server app, saving you from stopping and starting your application server or manually installing the app after a change. To use Quick Reload, after making your changes, open a new terminal window and navigate to your project directory. Then enter the command atlas-maven package. From the terminal where Atlas Run is running, you'll see Quick Reload pick up the change and load your updated app. So the third thing I would suggest is how to troubleshoot dependency issues. In my time working with Atlassian server ecosystem, I've been asked to look at problems with dependencies more than a few times. Maven manages dependencies based on the Maven project pom.xml. And this POM contains all the dependencies and Maven takes care of the rest. AMPS uses the Maven bundle plugin to automate OSGI bundle recovery management. And the import package instruction within your project POM lists packages required by the bundle's contained packages. By default, this will include an asterisk. The asterisk tells the Maven bundle plugin to import all reference packages. This header really has to be explicitly specified, and removing the asterisk from the header can result in dependency errors. So unless there's a very good reason for removing it, I would strongly recommend against it. Sometimes you may also find your build specifies different or incompatible versions of the same jar. In this case, you'll need to track down which dependency is responsible for them being included. The Maven dependency tree command provides a way to display all direct and sub-dependencies in a human-readable tree format. The Atlassian manifest tools are also useful when wanting to understand more about your dependencies. The tool can be used to examine the manifest file in a human-readable format. If you go to bitbucket.org/atlassianlabs/mftools, you can find out more. Finally, I would recommend using the latest version of AMPS. The Plugin SDK and AMPS are released independently, but you don't have to stick to the version of AMPS bundled with the Atlassian Plugin SDK. To keep up to date with the latest releases, watch AMPS announcements in the developer community forums at developer.atlassian.com/community. To specify the version of AMPS, include a -u switch after your Atlas command. So for example, -u and then the AMPS version, 6.3.17 for example. So, I hope this talk has helped you better understand AMPS, so you'll be able to get more out of it in the future. Now you have a deeper understanding, you will know what to expect when using it. If you'd like any more information about anything I've spoken about today, please go to go.atlassian.com/whatsampsanyway, and you'll find a list of links and resources.